Hello, myself Saurabh Noskor, Assistant Professor of Chemistry at Gargi Memorial Institute of Technology. In my previous lecture, I discussed about corrosion chemistry. Today I will discuss water chemistry. First, we will see some sources of water. There are several sources. First one is surface water, underground water, rainwater and seawater. And in surface water there are maybe river or lake or ponds, etc. Now we will learn hardness of water. What is actually hardness of water? The presence of multivalent cations, especially calcium and magnesium ions, are responsible for hardness of water. When soap is added to hard water, calcium 2 plus and magnesium 2 plus ion replaces sodium plus and potassium plus ion in the soap and gets precipitated. Hence, lateral formation is hindered. See, this is the formula for soap, RCOONA, and this is the cation which is responsible for hardness of water. When this soap is reacted with this ion, then calcium 2 plus ion will displace this sodium plus ion from soap. So there will be formation of such type of scam, and due to formation of such type of scam, lateral formation is impossible or lateral formation is hindered. So we have to remove this cation which is the cause of hardness of water. There are two types of hardness. First one is temporary hardness and second one is permanent hardness. Temporary hardness, this is due to the dissolved salt of bicarbonate of calcium 2 plus and magnesium 2 plus. And this temporary hardness can be removed by either boiling or Clark method. See, this is the cation and this is the anion. Actually, this complex is responsible for temporary hardness. So, calcium bicarbonate. This is the formula for calcium bicarbonate. When we will boil, this is the boiling process to remove this temporary hardness. When we boil this calcium bicarbonate, we will get calcium carbonate which gets precipitated. So, this complex destroyed, and due to the destruction of this complex, temporary hardness has been removed. So by boiling we can remove temporary hardness. And second one is Clark method. By this method also we can remove temporary hardness. This is our calcium bicarbonate. We can react with calcium hydroxide. Then these two on reaction will form calcium carbonate which gets precipitated. So this complex has been destroyed. So temporary hardness has been removed by Clark method. This is Clark method and this is your boiling method. And second one is permanent hardness. This is due to the dissolved salt of chloride or sulfates of calcium 2 plus and magnesium 2 plus, and this permanent hardness can be removed by the following process. So here anion is chloride and sulfate and cations are calcium 2 plus and magnesium 2 plus. What is softening of water? The process of removal of hardness of water is called softening of water. First process is lime soda process. First you have to know what is lime. Lime is nothing but calcium hydroxide and soda is nothing but sodium carbonate. Now this is the cation responsible for permanent hardness, and this is the anion responsible for permanent hardness. So we have to break or destroy this complex. When MgCl2 is react with this soda, means sodium carbonate, there will be formation of magnesium carbonate and NaCl. So this complex has been destroyed. So permanent hardness has been removed. Or you can destroy this complex by using your lime, calcium hydroxide. So there will be formation of CaCl2 and MgOH2. This will get precipitated and this complex destroys. So permanent hardness has been removed by lime soda process. Advantage of this process is very economical and less corrosion tendency, and disadvantage is this process needs careful operation and skill supervision. Next process is to remove permanent hardness is Calgon method. Sodium hexametaphosphate is known as Calgon. This is the molecular formula of Calgon. Na2NO4 This is cationic part and this is your anionic part. So this can ionize into cations and anions. Now the hardness causing cation can be trapped inside the anion. In this way, see, sodium having 1 plus, so 2 sodium plus will come out and this can go inside. So 2 sodium plus come out, 2 plus, and this calcium 2 plus will go inside. In this way, the complex anion, this one, keeps magnesium 2 plus or calcium 2 plus ion in the solution. So hardness causing cation is kept inside the solution. So in this way we can remove permanent hardness also. Next process is zeolite process or permutate process. This is sodium aluminosilicate. This is the molecular formula Na2Al2Si2O8 and X number of water. Or you can say in simple way sodium zeolite. This is your sodium and this is your zeolite. Zeolite is represented by Z. Z is this one. Okay, so this is your this is the complex which causes permanent hardness. This is cation and this is anion. So when this complex is react with sodium zeolite, there will be formation of calcium Z and Na2SO4. So this complex has been destroyed, so permanent hardness has been removed. Limitation of this process is presence of acid in water destroys zeolite. If you have some acid in water, then this acid will destroy zeolite. So this is the limitation of this process. And finally, this is the best process among 4 to remove permanent hardness. This process is ion exchange resin. The hard water is first passed through the cation exchange resin, or you can say cation exchange column. And this cation exchange column contains COOH carboxylic acid group, or this is SO3H group. Now this cation exchange column replaces hardness producing cations such as calcium 2 plus and magnesium 2 plus by H plus ion. Water is subsequently allowed to pass through the anion exchange column which contain amino group or hydroxyl group. Now anion exchange column replaces hardness producing anions such as chloride ion and sulfate ion by OH minus ion. So this is actually your cation exchange column. Here cation exchange column replaces this hardness causing cation by H plus ion, this one. So this can go there, H plus will come here, and this is your anion exchange column. This column will displace this Cl minus by OH minus. So Cl minus will come here, OH minus will go there. In this way, finally H plus and OH minus ion released from the exchange column combine to produce water. So they can combine to produce water. Now such example of water is free from all cations and anions and known as demineralized water, because all the cation and anion has been trapped by cation exchange column or anion exchange column. So now this type of water is known as demineralized water. The regeneration of exhausted cation exchange column is possible by passing a solution of dilute HCl, and the regeneration of exhausted anion exchange column is possible by passing a solution of dilute NaOH. Now advantage of this process is this process can be utilized to soften highly acidic and highly alkaline water, and disadvantage is equipment and chemicals are very costly. In my next lecture, I will continue this water chemistry. Thank you.